A+ലേക്കുള്ള വഴി ഇനി തനിയെ തുറക്കാം. Subscribe to the Enclaps channel. Ring the bell button and open success. It's that easy.
Hello. Let's consider situations where we define probabilities geometrically. We can see a circle here. This circle is divided into two equal halves. There is a white half and a black half. If I am putting a dot inside this circle, keeping my eyes closed, can you say the probability of putting the dot in the black half? For this, we just need to know what proportion of the total area of the circle is the black half. We can see that the areas of white and black halves are the same, isn't it? That is, if I put a dot without looking, the probability that the dot lies in the black half is same as it is in the white half. So we can say 1/2 is the probability. Now let's consider another figure. Here also there are two parts which are made of white and black colors. If I am keeping my eyes closed, can you say the probability of putting the dot on the black portion? We can easily see that 3/4 of the circle is black in color and only 1/4 of it is white in color. That is, if we divide the circle into 4 parts, 3 of them are black and only one part is white. Hence, the probability of the dot lying on the black part is 3/4. What about this figure? It is not very easy to identify it like we have done in the previous cases. It's alright. Let us divide the circle into several equal parts. We have divided the entire circle into 8 equal parts and 5 of them are black in color. That is, we can say if we are putting a dot on the black part, the probability that the dot lies on the black part is 5/8 quite easily. Likewise, the most important thing that we need to find out in the mathematics of chance is what proportion is a particular area of total number of parts. Hi Clappy, did you ever play this game?
Yes, teacher. I have played it several times.
Can you say the probability of getting a yellow color if I am rotating this?
Teacher, the probability of getting yellow color is the most, since most of the parts are yellow in color.
Yes. The circle is divided into 8 equal parts and 3 of them are yellow. Hence, the probability of getting yellow color is 3/8. Similarly, 2 out of 8 parts are magenta and hence the probability to get magenta color is 2/8. Also, for blue, it is again 2/8 since 2 parts out of total 8 are blue. Only 1 out of 8 part is orange in color. Hence, the probability of getting the orange color is 1/8. In general, we can say for the circle, since majority of the portions are yellow in color, the maximum probability is for getting yellow color. Since the portions that are blue and magenta are equal, the probability for obtaining these colors are the same. There is only one part that is orange in color. Hence, the probability of getting orange is the least. Consider another situation. Here we can see a figure. In this rectangle, 2 lines are drawn from the midpoint of the top side to the edges of the opposite side. We can see a triangle which is red in color formed by these lines. Now, I am going to put a dot keeping my eyes closed inside this figure. We need to find out if the dot is lying in the red triangle. For this, we need to find out what proportion of the rectangle is the area of the triangle. We know that the area of the rectangle is equal to length into breadth. Area of the triangle is half into base into height. From the figure, we can see that the base of the triangle is same as the length of the rectangle. Similarly, the height of the triangle is same as the breadth of the rectangle. Hence, we can say the area of the triangle is equal to half times the product of length and breadth of the rectangle. That is, area of the triangle is equal to half into base into height, that is half into length into breadth, that is half times area of rectangle. Hence, we can say the probability of the dot lying in the red triangle is 1/2. To find out the areas of complex figures also, we can adopt this method. For example, see this figure. Suppose we need to find the area of this figure. For this, draw a square that can completely contain this figure. Now, put some random dots inside the figure just like this. The value that we get by finding the dots inside the figure by total number of dots inside the square would be approximately equal to the value that we get by dividing the area of the given figure by the area of the square. For example, suppose there are 100 dots inside the given figure and there are a total number of 250 dots inside the square. Let's assume the side of the square is 7 cm long and hence area is 7 into 7, that is 49 cm square. If the area of the figure is x, then 100 by 250 is equal to x by 49, that is 10 by 25 is equal to x by 49, or 25x is equal to 49 into 10, that is x is equal to 490 by 25, or x is equal to 19.6. That is, the area of the given figure is approximately 19.6 cm square in this case. This method is called Monte Carlo method. Can you please try to solve more questions in the textbook using this method that we studied right now? You will check out if your answers are correct by cross-checking in the ENCLAPS icon, right?
3 ലക്ഷത്തിലേറെ വരുന്ന ചോദ്യോത്തരങ്ങൾ ഏറ്റവും കുറഞ്ഞ ചിലവിൽ സ്വന്തമാക്കുവാൻ ഉടൻ തന്നെ ഡൗൺലോഡ് ചെയ്യൂ Enclaps, the learning app.